Well, okay. Hello, everyone. My name is Eric Cal. I currently have the pleasure of serving as PTA for Congress Project. And I'll be giving you an update on the project today, on what we've been doing. So first, let me just introduce Congress real quick. I mean, what is it, right? So in a modern cloud, we have a bunch of services and controllers dealing with different aspects of the cloud. You have compute, you have network, you have storage, you have container orchestration, and many, many more things. Now, what if an operator wants to have a policy, for example, that says servers having access to sensitive storage must have strict networking isolation? Okay, where does that policy go? It crosses, it crosses several of these services, including compute, networking, and storage. So it doesn't naturally belong in any of these silos. So that's where Congress comes in. Congress provides a open and unified policy layer across the whole cloud. It would talk to all the different services in your cloud, gather data to construct a unified state of the whole cloud, and then evaluate your policy over the cloud. Okay. Now, how does it work? At a high level, the architecture is very simple. There are three pieces. First, there's the data. Congress gets data from webhooks and APIs, and then stores the data as tables and JSON. Okay, second piece is the policy. In Congress, policy is represented as a collection of data log or SQL rules, and these rules transform the data collected into policy decisions. These policy decisions can be used and queried by both humans and services. Finally, there's action. So what Congress can do on the basis of these policy decisions is to trigger API calls to actually affect change on the cloud. Okay. Now, what are the advantages of this architecture? Well, first, it's very extensible. An operator can plug in arbitrary data sources as needed by the use case, right? Like, policy is useless without the data to evaluate over. And second is that the policy language is very expressive. It's not limited by any fixed vocabulary or set of properties you can change. Okay, so an operator is able to craft, arbitrarily complex policy that exactly fits the needs of the organization. And finally, the language is also declarative. It's based on a well-understood declarative language, so it can be used to express clear and manageable policies and avoid procedural code and scripting and that kind of stuff. Okay. What are some use cases? Well, Congress, as I mentioned, is fully general purpose, but here are just a few use cases to highlight. Well, Congress is very good at monitoring the state of your cloud to identify policy violations. And these policy violations can be things like insecure setup, can be inefficient setup, or non-resilient setup, among others. Right. This is important, especially in a self-service infrastructure. And something else you can do on the basis of finding these policy violations and on the basis of policy is to trigger things based on these policies. So it can trigger API calls. And what is that used for? Well, a couple of examples are you could use it to implement advanced fault management policies or advanced auto-scaling policies. And another way to think about it is that Congress can be a really generic integration glue between services. For example, if an operator wants events and state from one set of services to trigger actions on a second set of services. Well, instead of having to build one-to-one integration between each of those services and running into the n square problem, Congress can be used to collect data from the source services, evaluate the policy, and figure out what actions to trigger in the second set of services. Okay, now that you have an idea of what Congress does and what it can be useful for, let's look at a couple of recent developments. Okay. All right, first is over the Stein cycle, and over the past couple cycles, we have built up its fault management capabilities specifically for the NFV use case, but really it's more general than that. So in particular, we have much improved integrations with Monasca monitoring service and newly added integration with Tacker orchestration. So as a result, Congress can provide advanced fault management policies that really can help deliver better SLAs. Let's look at this in more detail. Right, so the overall architecture looks something like this. On one side, we have the alarm services, such as Monasca, and as well as other contextual data from Tacker and Nova and Kubernetes and so on. Feeding data into Congress Policy Service in the middle. Congress Policy Service then consults the fault management policies the operator has defined to make policy decisions on what needs to be done in managing these faults. And finally, taking actions, triggering actions on the basis of these policy decisions by talking to the infrastructure managers and orchestrations. So what do these, I mentioned advanced fault management policies. So what does it look like? Right, so here's one sort of like simple but illustrative example we can look at. It's preemptively scaling out. So in many cases, you have monitors on really like mission critical applications. You have monitoring that can give you predictive fault signals, like, hey, a failure is likely to take place. So how can you respond? Well, one possible response is to just ignore it, especially in a very cloud-native situation. Okay, ignore it, failure occurs, workloads go down, load on the remaining workloads increase, and hopefully the auto-scaling component, sees that and adjusts accordingly. So that all gets you back to a good state eventually, but the drawback is depending on how many instances go down, what kind of failures take place, and how much load there is, you could have degraded service for some time. And that may not be acceptable depending on the application. So what's an alternative? How can we do better? So one thing that could be done is to estimate based on the predicted failures what kind of service disruption or degradation we may have. Then we can preemptively scale out as appropriate to minimize the chance of degraded service. Okay. Here, I'll run through an example of a policy that could achieve that in Congress. So this is going to be conceptual at first because the whole example wouldn't fit in a presentation like this. So on the basis of alarms predicting faults on hosts, as well, so this could be from Monasca, and instances data, for example, from Nova, this Congress policy can figure out which instances are running on these hosts and therefore likely to be affected. And combining that information of instance affected with VNFs data from, say, Tacker, the policy can figure out which VNFs are affected. Now, also by looking at other contextual data from monitoring, such as how much load and what kind of response time we're getting on these VNFs, the Congress policy can then estimate what the load would be on the remaining services after these failures take place. And finally, it can make policy decisions on which VNFs to scale out preemptively. Okay. So now I'll just give you a couple snippets of what these policies actually can look like. So first I'll look at computing the instances affected. So to compute instances affected, the policy will look at the host alarm table, look at the list of all the hosts which have this predictive alarm on it, then match that host name against the Nova servers table to find all the instances running on those hosts. At the end, giving you the top of the line instances affected table. So that's pretty simple. Now let's jump to the end and look at how one might make scale-out decisions on the basis of predicted load. Here's a really simplified case of saying, let's look at predicted VNF load on all the VNFs, right? Identify those predicted loads that's greater than 90%, and then populating a scale-out table with those VNFs, those being the ones that you scale out. Okay, and of course, a more complete policy would consider other things like the business impact of these particular VNFs and the availability of physical infra resources and so on. All right, so that's the new development on Congress in NFV fault management. So switching gears a little bit, I'm going to talk about a different new development that's important in Congress. Okay, so before the Stein cycle, Congress stores all the data in relational tables. And the relational data model is really simple, it's really useful, but it does have some drawbacks. So for one thing, it's very inconvenient to represent highly hierarchical data in relational form. And a lot of data on cloud is highly hierarchical, right? And along with that, it introduces a need to translate source data into tables. This means there needs to be a translation layer, and so if an operator wants to plug in a data source that's not anticipated by the developers, it can be a little bit complicated. So in the Stein cycle, we introduced JGRES, which is JSON data in Congress. So we adopted the hybrid data model of Postgres. So now, Congress can connect to almost any JSON API without any translation code. So what this means is quite powerful. This means an operator can just instantly integrate new data sources as use cases emerge without having to have a driver for it and so on, or translation layer. And so this is really important because, as Congress is a really general framework, the developers can't anticipate all the use cases and all the sources of data one might need. So this opens up a whole new class of use cases for Congress. Okay. Now, there's if you're interested in finding more about this, we don't have all the time here, but it's well documented in the new feature in the Congress documentation. All right. So, as we continue to really build out Congress to address needs, and we definitely welcome feedback. So any feedback, any suggestions, any ideas, we would love to hear that. In particular, if you have some thoughts on how Congress may be able to help you solve a certain problem you have, we would love to work with you to figure out whether that can be done, how Congress may be able to help. And so, to reach the community, the best way is to use the mailing list, OpenStack Discuss, using the Congress prefix. But also, absolutely feel free to email me directly at the email on the slide. Okay. And I'm just going to also point you to if you're interested in the NFV fault management use case, point you to this talk later this afternoon at 2:30. I will be giving a lot more details on that. Okay. So with that, let's open it up for questions if there's any. Yeah, okay, so let's go back. You're referring to these snippets? Yeah. Okay, right, so that's called data log. So it's it's a relational query language. So here, what it's doing, right? It's joining the it's joining the host alarm table with the Nova service table by matching on the alarmed host column or field, right? And so at the end, computing the top line right there, which is the instances that are affected. So it's a database query, right? And you can also write and you can also write SQL query, which is similar, but does have some additional features like aggregation and sorting and and many SQL features out there. That's all. So yeah, the idea is definitely to provide a policy language that is expressive, but limited. I know it's a little bit oxymoron, but expressive, but doesn't it's not raw Python that that can do all sorts of things that's not easy to understand, and can be hard to manage. Right. So this is really useful because you can easily compose things, because all of these are declarative rules, simply transforming data. They're simply computing one table from another. So there are no side effects. Okay, well, if there are no more questions, let's wrap up. Thank you guys very much, and definitely feel free to talk to me later. Thank you guys.